Welcome to Module 8, which is all about disturbances in watersheds. So we're going to begin our module talking about this image of Lake Champlain and the cyanobacteria bloom that we can see within this huge body of water. I want you to consider how this problem might relate to Module 6, or productivity in food webs, how this problem might relate to Module 7, or biogeochemical cycles, and also which environmental indicators, broad or very narrow, do you think are impacted from this problem? And you can refer back to Module 2 for that. So here are the key overviews. I want you to feel really good about the differences between ecosystem resilience and resistance, and also what we call the level and frequency of disturbances and their impact on biodiversity. Here's some guiding questions for you to think about in terms of human activity, restoration ecology, and different types of disturbances and their influence on biodiversity. So what is a disturbance? A disturbance is just an ecological event in which physical, chemical, or biological factors cause extensive changes within populations of species or the broader communities and ecosystems. Now, how well an ecosystem might respond to, in the moment, a possible disturbance, say a forest fire or a large ice storm or a thunderstorm, is known as resistance. How well is it able to cope with a changing environment that is possibly detrimental or damaging? Now, every disturbance will have some lasting impact, good or bad, small or large, on an ecosystem. And the rate or the ability to respond to that initial normal or undamaged system is known as resilience. So resistance is the ability to mitigate it in the moment. Resilience is how well you bounce back from that problem. Now, I have this image up here because part of our problem thinking about cyanobacteria is what are the biogeochemical and physical disturbances that are causing these algal blooms in Lake Champlain. And one of the largest disturbances that occur on an annual or monthly or weekly basis is runoff from different wastewater treatment sites. So where we process raw sewage and wastewater from household and residential and commercial buildings are aging and are outdated in the state of Vermont. So what happens when there's too much sewage or there's too much rainwater for the facilities to cope with? It's all dumped into our watersheds, which is causing some level of biogeochemical cycling and disturbances in Vermont. Now, humans with either Lake Champlain or somewhere nearby, like the Cotton Brook Basin, want to mitigate these problems. They want to restore damaged sites to their pristine condition. So we call this process, in terms of studying and implementing action plans, restoration ecology. However, there always are questions of bias, subjectivity, and values that come into play when we revision the past. So we look at this 100-acre mudslide a couple miles from our school. What trees should we plant there? How should we plant it? What should be the process in which we're able to restore the forest to what we think it should have been? And when we do fix these ecosystems, are we actually improving the systems, or are we improving them for the sake of nature? So there's a really good site right here that talks about how scientists have been able to use this natural system, this natural experiment, to assess how things are being impacted for both humans and natural systems. Now, a watershed is one of the main ways in which we can think about disturbances and interconnected systems, because all of the water in a particular land area will drain to one common point. Now, this is the Winooski River watershed in terms of thinking about runoff and erosion risk. And big parts of the Winooski watershed either have severe red or yellow moderate erosion risk, which has implications for runoff, land use, and nutrients, but also things that happen downstream. So we're really focused within the problems of ecological disturbances and their effects by thinking about how groundwater influences the surface, but also downstream ecosystems. Now, how those disturbances impact the pre-existing ecosystems is known as the intermediate disturbance hypothesis. Like everything in life, moderation is key. So when we think about disturbances like forest fires or affluent pipes releasing raw sewage, disturbances that are at a really high level or power or damage capacity result in erratic ecosystems that are really damaged, but also are really dominated by the most resilient or opportunistic species. You're not going to have a biodiverse ecosystem, which means things like geochemical cycles and food webs are really compromised. In the opposite extreme, low levels of disturbance allow dominant species to thrive. So if we don't have any of that disturbances, that's a source of competition. The most opportunistic species will be able to thrive as well. So having regular fires that are small and actually manageable are really important in the Western states to promote biodiversity. What does this mean for Lake Champlain? Currently, under the Clean Air and Water Act, the EPA can set what we call TDMLs, which are analogous to the maximum concentration that we talked about with PFOAs. It basically thinks about how much phosphorus should be in each part of Lake Champlain based on its size, its location, and its ability to mitigate excess phosphorus. Now, regions like the Missisquoi Bay or Mallets Bay have significantly higher levels of phosphorus than are recommended, which have really important implications for the ecological systems and their resilience to further disturbances. These disturbances in terms of land use, the more red you are, the more extensively you're causing the problem, result in annual or monthly disturbances, which are influencing the biodiversity, the biogeochemical cycles, and also the aesthetics of these different water sites. And it's a problem that we have to fix. We're actually mandated by law to fix the water quality of Lake Champlain. So there's a whole host of things we have to think about as we move forward. How do we use the land, and what resources are we using in terms of land use, and how does it influence natural systems? Can we make farming or wastewater treatment sites a beneficial thing and not a detriment to human and natural ecosystems? What is our impact on biological diversity? Part of this problem is seeing more and more common fish die-offs in Lake Champlain due to changing levels of nutrients and oxygen and temperature within these ecological systems. What is the monetary impact in terms of these problems? How much does it hurt your pocketbook, and does that influence your willingness to pay to fix these systems? And finally, we all have some biophilia, love of nature, aesthetic in our own world. We all value mountains or lakes or water systems or forests for their inherent beauty. And when these sites are compromised, is it our responsibility to fix it? Fix it to what? And how do we fix it? And do we have to sacrifice other human systems to restore this? Or can we find some level of balance? These are questions we'll think about as we continue to move forward.